Do you remember what you always start out with in a two-column proof?
The given.
The given, yeah. So the given in this problem, do you number them, or is that how you guys are doing it?
Yes, I number them.
Okay. All right. So QD is not parallel to UA. So if you don't like proof by contradiction, maybe we won't go that direction because that the problem is that I do think that is the right way to go, but I mean, since we don't know what the direction is here in this problem, but normally, like I said, you would just, because they're parallel, you would say that the alternate interior angles are congruent. This one's a little odd because, again, because it's, even though it's given, since that's given, it has to lead to something. So since these are not parallel, it also means that this is not a parallelogram. So I probably would go that direction next. I would probably say something like, I guess these aren't even in alphabetical order, but I would say something like QDUA is not a parallelogram.
Okay.
Have you done any proofs like this in class where you've done a not situation?
I was absent for this lesson,
Okay.
but before that we haven't.
Okay. Yeah, again, this is a little bit odd. So I'm not even sure this would be accepted by your instructor, but since we say it's not a parallelogram, that again, that's kind of by it's the definition of a parallelogram. Parallelograms require you to have two sets of opposite sides that are congruent, two sets of parallel sides that are parallel. You just don't have that here.
Right.
Let me just do a quick search here because this is just, it's just such an odd question to start out with. Do you have any way to tell me if this section of your textbook is using proofs by contradiction?
I look. All the other proofs on this homework have not been. It's just been this one that has had the contradicting part.
Okay. Yeah, I mean, if it were up to me, I would say this isn't even worth doing because it's so different than everything else you're going to see in this class that we should do a problem that's more like what you might see on a test or a quiz.
Yeah, in the examples, there's none like it.
You're not doing okay. Okay. Yeah, I'm a little uncertain how to proceed because if we don't use a contradiction, I'm not sure how we're going to do this, because by saying it's not a parallelogram, all that's going to tell you is that the sides are not congruent. And this, but it might be, see, it could be a trapezoid because might have one set of parallel sides, but this is cut by a transversal. If we say that, have you done anything with congruent triangles yet?
Yes.
Oh, you have. Oh, that's good to know. Okay. All right. That's helpful. So since it's not a parallelogram, we can say that angle U is not congruent to angle D. Okay, and that's a good start. And then we can say that this QD is not congruent to UA. And we can even go further and say that UQ is not congruent to AD, and therefore the triangles are not congruent. Since the triangles are not congruent, the sides are not, or the angles are not congruent either. So I think that's probably the direction I would go in this proof. Okay, so I basically proved that the triangles are not congruent, and if the triangles are not congruent, then the CP CTC does not apply in this problem.
Okay.
So I guess that's the direction I would go. And you kind of need to know that ahead of time. Like you have to kind of know where you're starting with and where you're going. So I guess I would probably say something like in number 3 here that let me pull up this picture one more time, that angle U is not congruent to angle D. And this is by the fact that this is not a parallelogram. Now, do you ever use the like converse or the contrapositive or the inverse in your proofs on the
Yes.
rows? You do. Okay. So I believe we want the inverse here. Just check. Okay, yeah, we want the inverse. Inverse of opposite sides, opposite angles are congruent in a parallelogram. So normally we'd say they're congruent because the opposite sides are congruent in a parallelogram, but since it's not true, we're going to use the inverse.
Okay. Okay.
All right, so that means that U is not congruent to D. So we're going to do the same thing with U and A. We're going to say that UA is not congruent to QD. Okay, the sides are not congruent, basically. Again, this is very awkward. You can see why you wanted help with this. But we would say UA is not congruent to QD. And again, that's also the inverse of opposite sides are congruent in a parallelogram.
Okay.
So we've shown that the sides are not congruent and the angle is not congruent. Now, we really don't have enough to prove that QU and DA are not congruent because they could be. Although if they were, then this would have more of a potential to be a parallelogram. So it's like sometimes it's hard to visualize, but basically because this is not a parallelogram, none of the properties of parallelogram apply, which means that the side here is not congruent to this side. Again, so it's actually maybe the same. We can use the same reason with a different set of statements there. We can say that QU is not congruent to AD. And therefore, we can say that triangle, so the one on the left, hopefully you've got that problem in front of you, or the triangle in front of you. And the order does matter here. Try to get this right here. QUA is not congruent to triangle ADQ. And this is also by inverse of side angle side theorem.
Okay.
Okay, so we've basically proven the triangles are not congruent. Therefore, angle 1 is not congruent to angle 2 by inverse of CP CTC. I really hope the next one is a little bit clearer so I can actually help you with something. This is not a great problem for us to start with.
Yeah, I think the next one is just a regular proof.
Okay. 21 is that right? 21?
Yes.
Okay. Now, do you normally get homework in this class every night?
Yes.
All right. You're still using that what is it, Geometry for Enjoyment book? I don't know if you've seen that on the front cover.
Oh, we don't have a book. He has all of the he has like the document online.
Okay. Yeah, and I've got this one too, but it's, if you look at the front cover, it's kind of funny. It says for enjoyment. I don't know that anybody has ever felt that way.
I don't think so either.
Yeah. Okay. So this one should go a little better. It says that angle M to O to P is a right angle. So that's a right angle. And we're gonna note that here shortly. I like to kind of draw some things in the figure before I go. And then RP is perpendicular to OP. RP is perpendicular to OP. Okay, so that means that this is also a 90-degree angle, and we want to prove that MO is parallel to RP. Okay.
Right.
All right. So this one's a little bit more straightforward. So our first statement is the very first given. We might as well say that angle MOP is a right angle. And that's given. Now, what I think is very important is to always figure out what that leads to. And that leads to the measure of angle MOP. What is the measure of angle MOP?
90 degrees.
90 degrees. Now, is it clear to you as a student, like the first one is just saying like, hey, this is a right angle. The second one is actually giving it a number.
I'm sorry, could you repeat that?
Well, yeah, it's kind of an awkward thing here. It's like you know that a right angle means 90 degrees, but you have to first say that it is a right angle, then say that the measure of the angle is 90 degrees. And it's distinct. It's like saying, you'll see this more often. It's like the two angles are congruent, but then you also have to define what the angles or the sides actually equal.
Oh, no, I don't do that.
Well, okay, but so you have to like this is one of the more challenging parts of the course, because it's not enough to just say that, oh yeah, it's a right angle, therefore it's 90 degrees. You have to specifically call it out here in the second line and say definition of a right angle.
Oh,
Like it's like, what does it mean for it to be right? Well, the measure is 90 degrees. And I think that's where it's like frustrating for students. So you really have to go back and like everything you have to justify now. You can't just throw it down on paper and say, yeah, it looks like a right angle, therefore it must be. It's like, no, you have to actually add that in.
right. Okay. Got it.
Okay, so the third step here is because this really doesn't lead anywhere. It's just that, okay, that's 90 degrees, is to probably go back to the next given. RP is perpendicular to OP. Okay, and that's a given, but it's like, what does that mean? And we wrote it down here. We said, oh, well, it means it's 90 degrees. Okay. And so now we have to say that the measure of angle, and you got to be very careful because it is angle P, but we might go OPR because that's not what RP perpendicular OP says. That it just says they're perpendicular. You have to say the measure of angle OPR is 90.
Okay.
Or equals 90 degrees is also okay. Okay, and that's definition of perpendicular line segments. So a lot of times students don't know what to put over here on the right, and maybe you're one of them. A lot of time it's definition of, and then, well, what is the definition of? Whatever you wrote in the previous line. Like you'll get close enough. See, I wrote right angle, perpendicular line segments, that perpendicular there.
Oh, okay.
So often you can just kind of, I mean, this isn't like we're not expecting you to be really great at these things, but getting closer and closer to doing them. So here's what we have so far. We have that MOP is 90 degrees, RPO is 90 degrees. Okay,
Okay.
that's good. Now, if we go back to what are all the things that you know about two parallel lines and a transversal? Can you list or name a few of those for me?
I know the alternate interior angles.
That's right.
Um,
Anything else?
the like corresponding angles.
Yes, very good. Okay, anything else? How about things that are not just congruent? Are there any things that add up to something?
Um, the like supplementary and complementary.
Yeah, so what's supplementary?
Uh, when two angles are added together to a 180.
Okay, now out of these angles, hopefully it's not too small to see. Out of these angles, which are supplementary?
Uh, angles 1 and 2 and angles 3 and 4.
What about 1 and 3?
Oh, yeah.
Yes, and that's the one we need here. So do you see how, and this one's, it's like, so a lot of times in this course, you have to do the following. You have to take a figure and you have to reorient it. So I'm going to reorient this figure down here. And hopefully that will help, help with understanding this. Let me actually make sure I do this correctly. Yeah. All right, so here's M, here's O, here's P, here's R. And we have these two angles are 90. And we really want RP and MO to be parallel. So if since the angles add up to 180, they're called the same side consecutive angles.
Right.
You remember that? So we can say, well, now we have to say that. Now we have to say, okay, the measure of angle MOP plus the measure of angle OPR equals 180. And we're not, there's times when it's just an algebra step. This is just, I guess I would just say, definition. No, it's not definition supplementary. It's, yeah, I guess it is. We'll go definition of supplementary angles. Because to two supplementary angles, two angles, they add up to 180.
Right. Okay.
So that's what we're saying here. It's like, oh, and like that's where maybe it's like, oh, well, that's good. Because if you have same side consecutive angles adding up to 180, well, that means that the sides must be parallel. And that's the whole point here. It's like, oh, these add up to 180. This P and this O, these angles add up to 180. Therefore, RP is parallel to MO by the converse of the same side consecutive angles add up to 180. So like sometimes you got to think of it backwards. You got to think of like, okay, if they were parallel, what would you then be able to say? You'd say that this angle and this angle add up to 180. Why? Because they're same side consecutive angles.
Right.
So it's same side consecutive angles that add up to 180, but it's the converse of that.
Right.
Because if it was, so when you're going backwards, you always use the converse. Is kind of what hopefully they're saying that in class. And then you got MO parallel to RP.
Right. Okay.
Okay, so a few other points here, and we'll just close out here in a minute or two. You should always try to at least write the last sentence or statement, even if you don't know the stuff in between. And you should always try to like fill in some of this, even if you can't get all the way through it. Because you'll find that you actually fill these things in actually from not just from start to finish, but you might do a few in the beginning, a few at the end, and then maybe get them all in there. They don't have to be done linearly. But these are very difficult. The first time you see them, you just feel like they're impossible.
Yeah. Yeah.
All right, Gracie. So that's probably it for now. You want to let your brother know that I'm available. He can either jump on or log in on his own.
Yes, he's right
uh,
here. I think I'm just gonna hand the computer to him.
Sounds good. Thanks for letting me help you. I'll talk to you. Hope to get to help you more this semester and school year.
Thank you so much.
You're welcome. Bye now.
Bye.
Hi, Joaquin. Are you there?
Yes. Hello there.
Hey, nice to meet you. My name is Matthew, and
to meet
your mom said you're going to UHS. Is that right?
That is correct.
Cool. And you've already kind of got your eyes on college, a couple of colleges. You're waiting to hear back from one in California as well. Is that true?
That is also correct. I have
Awesome.
been accepted to 3 so far.
That's great. That's great. And I think mom mentioned you were going to maybe do something math related or technical or science or something in college. So it's the goal here is to improve your math, not just for this school year, but for college. So I told your sister this. I don't know if you saw. I'm sharing this screen, and we'll work on some problems, whatever you want us to work on today. But at the end, I send you a PDF of the notes, and then we're also screen recording. So I'll get you a link to that, so you can watch it later on. If you need to go back, if you missed something, or studying for an exam, things like that. Now for future lessons, I'm happy to help you with any of your classes. I think your mom mentioned you have economics, some sort of AP economics class. Definitely able to help, and you could just sprinkle in questions, or if you want to dedicate an entire lesson to something, that's totally up to you. But just consider me a resource to help you for whatever you need during our time together.
Awesome. Thank you.
So with that said, what can we work on today, or what's going on in class? Can you tell me what you guys are working on?
Right now we're doing sum and difference formulas, and I'm not really understanding them as well as I thought I would.
Okay, so sum and difference formulas, very good. You're clearly in a trigonometry course by saying that. Let me pull up something for you, and because this is going to help you. Have you been given a reference sheet in this class yet?
I think so.
Okay, so I'm going to drop this one in the chat. I really like this one. I give this to all the trig students, whether they're in high school or college. It's got all the formulas you will ever need for this class. And it can be a little bit overwhelming, frankly, the first time you see it. But the sum and difference formulas, let me just snip that in just to make sure. And these might be slightly different than what you've seen in your book, but it's something like this. Is that right?
Yes.
Perfect. Okay, so the actual use of these formulas is not that difficult, but again, it kind of is overwhelming at first. Let's just talk about a little bit about how to actually figure out how to use these. So alpha and beta, you may have to figure out alpha and beta depending on your problem, but let's just say they're given. And I'll explain that here shortly. The way these formulas work is like if you have a plus, you get a plus over here because it's the top symbol. If you have a minus, use the minus, and the order doesn't matter. It's got to be sine alpha, cosine beta, plus or minus, cosine alpha, sine beta, whatever that is. Now for cosine, notice it flips. Okay, plus becomes minus, minus becomes plus. And by now you probably know whether your teacher is going to allow you to have a reference sheet or not, or if you're going to have to memorize these. Do you know?
Yeah, he said we're gonna have a reference sheet.
Perfect. So you should get it down however you want, but you've got to have this, and I'll just snip it in every time we need it today.
Okay.
Tangent is it comes in a couple of different forms. This is the kind of the reduced form, but you can always do, it's also equivalent to sine alpha. Basically, it's still equivalent to sine over, I don't want to get the formulas in there. It's still equivalent to sine over cosine.
Right.
So if you do a sine and a cosine, you don't have to redo it for tangent here at the end. All right,
Okay.
so let's just look at a very simple example here just to see, and if you've got some from your book or homework or online stuff you want to show, let's just do this. So here's a kind of your classic question. sine x plus 2 pi, we know that this equals sine x. Okay,
Okay.
because sine has a period of 2 pi, so x shifted 2 pi left or right, it's going to be sine x. But we're supposed to prove this. You've probably been doing that in this course. Prove it really just means like use the formula to make sure it works out. So what I like to do, and it's a little bit easier for me because I've got the technology here. I'm going to snip the sine formula and I'm going to lay it out underneath this. But what you want to be able to do is figure out, well, what's my alpha? What's beta? Okay, so your problem alpha is x and beta is 2 pi.
Okay.
So you can start formulating now. It's sine alpha, sine x, cosine beta 2 pi. Now is it plus or minus in this formula? We have a plus here.
Is a plus.
It's plus because it's the top one there. Plus cosine x sine 2 pi. Now, how comfortable are you with your unit circle?
Not very.
Okay,
To be honest.
that's okay. And I'll help you try and figure that out here. For now, if you've got that that link pulled up, it's on page 3. There are some that you probably do need to know right away, which is definitely the ones on the outside of this.
Right.
So where's 2 pi? Can you tell me that on this? Is it A, B, C, D, or somewhere else?
I think 2 pi is A, right?
Yes. Yep. Exactly. Go all the way around. It's A. So X is the cosine value. Y is the sine value. Do you know the ordered pair that goes there at A?
1, 0.
1, 0. Good. So if you know the ordered pair and you know that X is the cosine and Y is the sine, we have enough to be able to answer this. Okay. So what is the cosine of 2 pi? It's the X value. It's the X value there, which is 1. Plus the cosine of X and then the sine of the Y value. Y value there is 0. And sine X times 1 is sine X. Cosine X times 0 is 0. And we've done it.
Oh. Okay, that makes sense.
Now this is a very trivial example, I'll say, and I don't mean to like demean you at all in any way. That's not what I'm trying to say. I'm trying to say like this is not what you're going to see in a test or a quiz.
Right.
Okay.
Yes.
So let's give you one that you might see on a test or quiz. So here's one. What is the cosine of 7 pi over 12? Okay. And your first thing you might say, well, hey, Matthew, that's not a sum and difference. And I'm like, you're right. It is not a sum or difference, but it is a sum and difference problem. And we're going to use the cosine formula for this. So you as a student have to figure out, well, how do I get 7 pi over 12 from adding 2 things or subtracting 2 things? And the game is you have pi over 4. Sorry, pi over 3. Let me do these in the right order. Pi over 4, and maybe pi over 2, maybe pi to use. Okay. So I'll help you out here. If you were to add up pi over 3 and pi over 4, guess what they add up to?
Pi over 7.
Okay,
No,
so
2 pi over 7.
So when you're adding unlike denominators, you got to make a common denominator, right? So
Oh, right.
it's going to be 12 and 12. So you're multiplying. Actually, let me not do it this way. This is very unclear. Apologize. Pi over 3 plus pi over 4. If we want to make a common denominator, we're going to switch. We want 12 on the bottom. This gets multiplied by 4 and 4 on the left and 3 and 3 on the right. So you get 4 pi over 12 plus 3 pi over 12. And what does that add up to?
7 pi over 12.
Yes. Now your instructor expects you to be able to do this. Okay. And I'll try and go through a few examples depending on how much time we have to like show you the ones that you might see. This is a common one. This is, maybe a quiz question. I don't know. But once you figure out what they break apart into, then it's just using the formula. Like there's no There's nothing complicated now. Now, let me grab the formula for cosine again. If you had to memorize these, I would give you some tips on how to do that, or send you out to TikTok or something. Find someone who's more creative than me that comes up with these things. But basically, your alpha and your beta are known now. Pi over 3, pi over 4. So your cosine pi over 3 plus pi over 4 is cosine pi over 3,
Okay.
cosine pi over 4. Now, is it minus or plus next?
Minus.
It is minus sine pi over 3, sine pi over 4. So if you can get this far, you're really in good shape, because the rest of it is just unit circle stuff. Now, you've got that link. Could you go to your unit circle and tell me the cosine of pi over 3? And again, x is the cosine, y is the sine, meaning x is the first value in that ordered pair, y is the second value in that ordered pair. Can you tell me what cosine pi over 3 is?
Sure. 1 second.
Yep.
Pi over 3 is the cosine would be 1/2.
That's right. And what is cosine pi over 4?
Root 2 over 2.
Root 2 over 2. I switch to parentheses when I've got more complicated expressions. How about sine pi over 3?
Pi over 3, that would be root 3 over 2.
Okay.
And
Anything
then,
else? Sine pi over 4?
Sine pi over 4 would be the same as the cosine, root 2 over 2.
Perfect. Okay, now on the left here, you multiply the tops and you multiply the bottoms. So you get square root of 2 over 4. On the right, square root of 3 times the square root of 2 is the square root of 6 over 4. Now you can combine the numerators, but all you're doing is putting everything into one fraction. You can't actually subtract the square root of 2 or square root of 6 from the square root of 2.
Because they're not the same.
They're they're unlike terms. There's some kind of some funny memes or things out there, to the to like a physicist, the square root of 2 is 1.734 or something, and to a statistician it's 1.7, and to an engineer it's just 2, but to a mathematician it's the square root of 2.
Yeah.
So it is what it is. Like it's nothing, it's not friendly, it's just what it is.
Right, I get you.
Okay. Now the whole reason I had you do this is that if you go to your unit circle, there is no 7 pi over 12 on your unit circle.
Oh, that's true, huh?
So that is why you have to use these sum and difference formulas. And they're all kind of like this. They're all kind of like not all that ideal.
Right.
Okay. So that's just the way this goes. It's not, sorry. It's like, we wish it was nice, but they're not. So let's look at another problem here. Let's go the sine of 15 degrees. Okay, and I'll point you to your unit circle if you want. Is 15 degrees on your unit circle?
No.
No, but you have 30 degrees, you have 45 degrees, you have 60 degrees. Can you get 15 out of any of these numbers?
You can get 15 out of 45.
But you have to use 2 of them.
45 and 30.
Sure. So you could do the sine of 45 minus 30. Now, do you think that the sine of 60 minus 45 also works?
Yes.
Yes. So they both are good. Do you have a preference here for which one we pick?
45 over 30. 45 and 30, sorry.
Very good. So we're going to grab the sum and difference formula. And, for tonight, oops, that's not what I wanted to do. I wanted to snip the formula. Okay, so I'm snipping in the formula each time. It's kind of like when you learned quadratic formula a long time ago. The more you write it down, the more you'll remember. I know you got a reference sheet, but it does help. So
Yeah.
that's your alpha, that's your beta. So you can write it wherever you want, but it's sine 45, cosine 30, okay, minus cosine 45, sine 30. Okay, so can you go to your unit circle and tell me these values?
Yes, give me 1 second.
Yep.
Sine 45 is √2/2.
Okay,
Cosine 30 is √3/2. No. Yeah. Yes.
let me just pull mine up here. Yep, that's good.
And then cosine 45 is √2/2.
Okay, sine 30.
And sine 30 is 1/2.
Very good. So this looks a lot like the last one.
Yes.
Now, this is important. They always have the same denominator, always. So if you get like a different denominator, you have done something wrong.
Got you.
Okay, so that's a little check there. To me, it doesn't matter how you write it, but your instructor probably wants to make it a little more compact like that.
Got it.
All right, let me see. I'm just gonna look at a worksheet here to see what other types of problems there. This is like, I call this the forwards problem, where we're doing the sine alpha beta and going forward. There's also going backwards. Okay, so here's a more difficult problem for us to look at. Did you want us to do anything else tonight? Because this, we could probably just spend another 5-10 minutes on this.
No, this seems.
Is it? Okay.
Yes.
All right, so here's a test question. Okay. This is a legitimate test question. You're like, okay,
wow.
I've been giving you like easy ones. Let's increase the difficulty. So again, 30, 45, 60, 90. You can use anything you want on your unit circle. But you got to get to 105. Now, again, you can go negative.
That is true.
Any idea how you might proceed here?
Um,
And you can add or subtract.
I think I have an idea.
Okay. What do you got?
-90, -45, and +30.
Okay, you can only use two of them.
Oh, well then I have no idea. Oh wait, no, -16 and 45.
Yeah. So the reason you might want to do some more practice problems in this, and you don't even need to do them all out, is you need to figure out what you're adding and subtracting. That is the hardest part of this, because once you figure out that it's -45, -60, or plus -60, however you want to do it, you just go and grab your formula and you work this out from there. Now, tangent's a little more work. You've already figured out in this course, there's a lot of writing, a lot of stuff you got to do. But in principle here, I mean, you just get the alpha and the beta and you're basically done. Okay. So we got to be careful here though. Alpha is -45. You got to decide whether you're doing plus -60 or -60. And it doesn't matter to me, but what do you want to do?
I'd rather do -60.
Okay. So that means your beta is 60 and this is a minus problem. And your alpha is -45. Do you see the difference there? Because it affects where you are on the unit circle to get these answers. Is that clear?
Yes.
Okay.
Yes.
Okay. So we're going to go tangent -45. Okay. And because it's a minus, we're going to use the bottom one here, minus tangent of 60 over 1 plus tangent -45 tangent 60.
Okay.
What is unclear about this? And if because I want to make sure you understand. We're just applying the formula.
I'm just a little confused. Why are we doing, can you explain again why we're doing the minus on top instead of the plus, and the plus on bottom instead of the minus?
So we're using, so the tangent formula, just look at the tangent formula here. Whatever symbol it is, if you use the plus, you're using the top one and then the top one. Like,
Okay.
think of this plus minus as there's a top and there's a bottom. And
Mhm.
whatever you like, let me highlight it because that might actually help here. If you go with the plus, you're going with the top one, which might be a plus or a minus. And if you go with the bottom one, you're going with the bottom one.
And because we're going with minus 105,
No,
It's
it does not. It does not. Hang on, I'm interrupting you because it does not have anything to do with the minus 105. It has to do with how you broke it up.
oh, okay.
You chose, and that's why I was asking you, and maybe you didn't understand the full consequences of that, which is fine. But I wanted you to like decide, do you want it to be plus negative 60 or it's subtract 60? Because that affects, that affects your beta here and your
Okay.
alpha. Like you're like here, let me be a little bit more clear. You're doing this minus 45
Mhm.
minus 60. And this is, so alpha is minus 45 and beta is 60, but there's a minus between them.
Okay.
Now, in the tangent formula, these always flip.
Got it. Got it. I
Okay.
think I get it now.
Now from here, this is a matter of just, going to your unit circle and like, okay, what is tangent of minus 45? And on your unit circle, we'll just see how you're doing that. You're looking at your fourth quadrant. Let me snip that in. You can tell me if you got it or you don't got it or whatnot. But you're looking right here at this one. This is minus 45.
Okay.
And can you tell me what tangent is there?
It's, hold on. I,
So tangent is always y over x.
right.
So
It's,
minus square root of 2 over 2 over square root of 2 over 2. And they're the same. Like it wouldn't matter if it was minus, p over p. Like it doesn't really matter. They cancel and you get minus 1. So if it's the same on the top and the bottom, except for a minus sign, it becomes minus 1.
okay.
But more generally, tangent is y over x. So we're going to need that for the 60. So this becomes minus 1 minus, we got to get the tangent of 60, 1 plus minus 1, we got to get the tangent of 60.
Okay.
So tangent of 60, you're going to the first quadrant here. And you just go down here. So you go to 60 degrees, right? So it's right there. And tangent is y over x. So the y value there is square root of 3 over 2 over
1/2.
1/2. Okay. And whenever the same bottom is the same, it just becomes the
Root
tops.
3 over root 3.
Root 3. So we're going to go back and we're putting that in the positions that we left out. Tangent of 60, tangent of 60.
Okay.
All right. So let me just copy this down. Again, I'm going to send this to you as a PDF at the end. I do encourage you to take notes, but maybe not for today. So this becomes minus 1 minus square root of 3 over 1 minus square root of 3. Now, these are in parentheses. You're not able to just cancel those out.
Right.
Okay. So some instructors accept this right here. Like they're like, yep, you're good. You got it. Others want you to rationalize. What does your instructor want you to do?
I think he said rationalize. I'm not entirely sure.
Yeah, so like if this were a 10-point problem, like you're probably at 8 out of 10, 9 out of 10 maybe here, but rationalize is an important final step. It basically means to get rid of the roots. So you do that by multiplying the top and bottom by what's called the conjugate. And it's 1 plus the square root of 3, 1 plus the square root of 3. So the conjugate is the same thing, but with see how these are opposite in sign in the middle?
Yeah.
Okay. And then you got a FOIL. And this, there's a little bit of work here, but it can be done. So the bottom, we'll do the bottom first. You get 1 plus square root 3 minus square root of 3 minus square root of 9. Okay.
Okay.
And the idea is that when you rationalize, you always get a nice number on the bottom. So do you see how the square root of 3's cancel?
Yes.
And then square root of 9 is 3. So it's really 1 minus 3, like that.
Right.
In the numerator, you got a FOIL. So you get -1 minus square root of 3 minus square root of 3 minus square root of 9 on the top. So the minus square root of 3's do not cancel this time. They combine. The square root of 9 is 3. So you have -1 minus 3 is -4 minus 2 square root 3. And then from here, you divide each of them by
2.
-2. Yeah. And you end up getting something kind of reasonable, after all that.
Got it.
So there's a fair amount of work to do after you get to this point. So I might ask my instructor, like, hey, do I need to rationalize, or is there a point deduction if I don't? Because you could see it does take some effort here, and you might, want to make sure you get through everything else.
Right.
That. All right. So that's it for us for tonight. This is kind of the format. How's your AP economics class going?
Pretty bad. I am not doing too well with it, but I am starting to understand a little bit more right now.
Okay. Do you like economics though? Like in terms of like the subject, like do you find it interesting, or do you find it like it's not interesting because there's not enough application? Give me your.
I feel like economics has its uses, but I'm not a big fan at the moment.
Okay. What's your favorite subject, or what do you enjoy most, sort of in that school setting? And is it the classes, extracurricular activities, sports? Give me some more information about you.
In the school setting, I like a lot more like extracurricular and fun ideas. So like theater or robotics or computer science. I like having something to do, something to just ease my mind off things.
Cool. So are you doing any robotics classes? Any
I'm in a
programming
I'm in a robotics club,
club? Okay.
and I want to go to a school for a computer science degree in college.
Cool. I had a guy working for me, computer science degree out of Colorado State for a while. He really took off. He really enjoys it. So I hope you get to do that. Well, that is it for us for tonight. Is your mom around? Or if she's not, I'll give her a text or call at some point to give her some feedback on the lesson. But thought you did great. I hope this helps.
Thank you.
But
Yeah, she's on her way right now.
Oh, sounds good.
Yeah.
Hi, Matthew.
Hi, Patricia. How are you tonight?
I'm good. Thank you so much for meeting with both
Of
us.
course. So my booking is usually more standardized than just me sending you an email. There's a technical problem that is unresolved that I have no control over. But for future, I'll go over that with you for the future ones whenever it's fixed. But I'll give you some feedback. So Gracie's in a really weird part of the geometry course with these proofs that almost every student struggles with. They always, they get frustrated. They're hard to do. It's hard to, what's hard for me, which I can do in almost every other subject, is give her like problems. With geometry proofs, it's like impossible because they're all one-offs. They're just do this proof, and they always save the one for the test or quiz for the test or the quiz. They don't get like a reproduce, they don't get one that they've seen before. So I could just see that was, struggling. Probably, definitely not my best moment either, helping her out with that stuff, because it's just weird. It's just very weird. But it does get better. They moved to more, I don't know, I'll say algebraic geometry, where there's a lot more solving, and the proofs go away after the first half of the year.
Okay.
And then with your son, he if we continue to work together, I would definitely like to spend some more time with him learning his unit circle. Could tell that this was just something that he's not comfortable with yet, and I've got some exercises that he can do to get faster at. But I'll just sprinkle it in as needed throughout the lessons. But this is the format. So at the end, I'll send you guys a link to, or I'll send you the notes by email, which is a PDF of the screen, and then I screen record so the students can go back and look at it later on, if they've got questions or if they want to study for the exams. And I thought they both did great. Hopefully they like the format. It's really immersive. Hopefully they can do this going forward, and hopefully I can help you guys.
Perfect. If you could send me, I'll follow up with them, but we're at
course.
the point, we're at the point with their grades that it's not really an option for them. So we're gonna make some time in our schedule and figure out what we can do. So I will talk to them, and then if you can send me the information on prices and times and how we sign up, that would be fantastic.
Yeah, actually, let me go through that right now with you since I've got you on the call here. I'm gonna stop recording. I meant to do that earlier.